In this video, we're going to have a look at how we can differentiate using the quotient rule. We use this rule when we have expressions that are set up in a fraction format to make it a little bit more efficient to differentiate them. In our first example situation here, you can see we're asked to differentiate y equals 2x all over x plus 4. So you can clearly see that we've got two expressions, one on the top and one on the bottom. Now, with our current knowledge of being able to differentiate sort of standard terms or using the product rule, we could bring up the bottom expression to the power of -1 and use our product rule. But sometimes our expressions are a little bit more complex. So let's see how the quotient rule can help us. So given this setup where we've got a function in the numerator and a function in the denominator, we can differentiate by writing the bottom times the derivative of the top, subtract the top function times the derivative of the bottom function, all over the bottom function squared. So this is something that I like to remember to say to myself to get used to using the quotient rule. Write the bottom times the diff of the top, take write the top times the diff of the bottom, all divided by the bottom function or expression squared. So let's see if we can actually put this in action for our first example. So let's differentiate. We're going to write the bottom times the derivative of the top, which is 2, subtract write the top, 2x, times the derivative of the bottom, the derivative of x plus 4 is just 1, all over x plus 4 squared. Now we can see that we've basically been able to use the quotient rule, but we could simplify this. I can see I can collect some terms at the top. So at the top I've got 2x plus 8 take 2x all over x plus 4 squared. So I can simplify this down to 8 over x plus 4 squared. We don't need to simplify unless it actually states that. We can just want to use the quotient rule, but often we're trying to find stationary points or a max or min. So it's easier for us to simplify. In our second example, we've got y equals 2x squared over 3x subtract 1. So looking at using the quotient rule, we're going to write the bottom times the derivative of the top, subtract write the top over the derivative of the bottom, all over the bottom squared. Okay, let's see if we can simplify this a little bit. We've got 12x squared take 4x take 6x squared. So I've certainly got some common terms in the numerator. So we end up with 6x squared take 4x all over 3x minus 1 squared. And I'm going to leave my simplification there. So a really nice and easy rule to help us differentiate some not so friendly equations or expressions. So now it's your turn to have a go at differentiating some of these functions using the quotient rule. So just start by trying to make sure you can get the quotient rule written out, and then if you see that you can simplify in some way, then go ahead. In part B, because we have a bracket all to the power of 2, so greater than the power of 1 at the bottom, it does get a little bit more complex if you're going to simplify. And also we're going to have to use the sort of chain rule here to make sure that we can differentiate the bracket to the power of 2. Once you've had a go at those two questions, I'd like you to have a go at question number 8, which is find the equation of the tangent to the curve y equals x squared plus 6 over 2x take 3 at the point 3, 5. So remembering that the tangent is the equation of a straight line at that point. So first we need to find the gradient of that straight line and then substitute the point in to find the actual equation of that tangent. So pause the video now and have a go at those two parts from the previous question 7, and then have a go at this question 8. And then unpause the video to have a look at some solutions. Okay, coming back to these two example questions here for you to use the quotient rule. Starting with our derivative, we're going to write the bottom, diff the top, take right the top, diff the bottom. Be careful that it's a -1, all over the bottom squared. We could simplify here, although it's unless we are asked to or need to in order to solve, we can leave it as just showing the quotient rules used. But this one will simplify down to 39 over 7 minus x all squared. In part B, a little bit more complicated, the derivative. Just use the chain rule in here to differentiate that bottom function. Now we could go ahead and simplify here, and we can see that we could take out some common terms with that 2x plus 1 in the bracket. And this should simplify down to the following. In fact, we could leave off those. Oops. Don't need that bracket in the bottom because we've only got 2x plus 1 is not to the power of 2 as we've simplified. See if you can simplify down, but it's not necessary. In question 8, we do need to simplify a little bit to find that equation of the tangent. So when we simplify this one down, we end up with 2x squared take 6x take 12 over 2x take 3 all squared. Now I'm going to stop there because I don't really need to simplify any further because I want to find the equation of the tangent. So I need to know the gradient value when x is 3. And I end up with a value of -4 and 3. So the tangent equation is looking like y equals -4 and 3x plus c. Substituting in the 0.35. C is going to be 9. So we've got y equals -4 and 3x plus 9 as the equation to the tangent at the 0.35 on this curve.